Welcome to next round coding. Today we're going to solve LeetCode 45 Jump Game 2. So it is basically the extended version of Jump Game. If you have not solved the Jump Game problem, so try to solve the problem first, then come to this one. So basically the problem states that you are given a zero index array of integer norms of length n. You are initially positioned at zero index. Each element norms I represent the maximum length of forward jump from index I. In other words, if you are at index I, you can jump at any index I plus j where j is lesser than equal to norms of I and greater than equal to 0 and I plus j lesser than n. Return the minimum number of jumps to reach the index n minus 1 and the test cases are generated such that you can reach the index n minus 1. So first of all, try to understand the problem first, then we come up with a solution. So here is the example one. So basically we are at the first index at index 0 and the value given here is 2. So we can go to two step forward. So from 0 we can go to index 1, from 0 we can go to index 2, right? Now if we go to index 1, then from index 1 we can go to three step forward. So from 1 we can go to 2, from 1 we go to 3, from 1 we go to 4, right? And we can reach the last index from 1, right? Now check other possibilities as well. From index 2 we can go to one step further because here the value is 1. So from 2 we can go to only 3, and from 3 index we can only go to the next index, means index 4, because the value here is 1. So now check what is the minimum number of jumps you need to take to go from index 0 to index 4. Okay, so if you take from 0 to index 1 one jump, and from index 1 you can directly jump to index 4. So there is a one jump here, there is another jump here, so total two jumps you need to take to go to 0 to 4, which is the minimum one, and there is no other possibilities to go from 0 to 4 with lesser than value of two jumps. Okay, now come to the example 2. In example 2 we are standing at index 0. The value here is 2. So from index 0 we can go to 2 step forward, means 0 to 1 and 0 to 2. Now 1 is reachable from 0. From 1 we can go to 3 step forward. So from 1 to 2 is possible, 1 to 3 is possible, and 1 to 4 is possible as well. Now check the other possibilities. Now from index 2 is reachable from index 0 and index 1 both, but from index 2 we can't go further because the value here is 0. Now come up to the next index, index 3. Here is the value is 1, so we can only go one step further from here, which is the last index. Now check what is the minimum jump we need to take to go from index 0 to 4. We can go from 0 to 1 first with one jump. Now from 1 to we can directly go to the index 4. So it is one jump and another jump. So minimum jump we need to take is 2. So our answer will be 2 because there is no other possibilities which have a value of lesser than 2. Now let's see the brute force approach first. So basically we can try out all possible combinations. To try out all possible combinations, we need to do a recursive call here. So basically we can create a recursive function like solve, which will be a int function. It will take the array, the size of the array, and our current position of the array. So if we reach the last index, means pos equal to n minus 1, we can simply return 0, right? Now, what is the all possible combinations? We need to go for all possible jumps from the current index. So if int j from 1 to j lesser than equal to arr of pos j plus plus, we need to check which gives us the minimum answer. So we need to take a answer which will be initialized with a very large number and just minimize the answer and call the next recursive function. So if we need to take one jump here, right, and check call the next recursive function solve from our next index means clause plus j, and at the end return answer, right? This way we can solve the problem, but if we try to do this, its complexity is very high. The time complexity for this approach is 2 to the power n, which is very high. That's why it can give us a time limit exceeded. Now we can do a memorization here. If we do a memorization, then the time complexity boils down to big O of m square. So now try the brute force code first. So we need to create a function, a recursive function named solve, which will be taking a vector of int nums and our current position. We need to take the size. Now if we reach the last index, we need to return 0 and we need to initialize our answer with a very big number. Now check the all possible combinations here and minimize the answer with the current return function value. So we need to check one jump from here and call the next recursive function. So it will be nums and position will be updated by false plus j and the return answer at the end. Now let's call the solve function from here. Now current position starting position will be 0. Now try to run it. Now here it is getting running fine. Try to submit it. So it gives us runtime error because we are going out of bound. So we need to update here. If the position is greater than equal to n minus 1, we need to return 0 from there. Now if we run it, running fine, try to submit it. Yeah, as I told you, it gives us time limit exceeded. Now we need to memorize it. So for doing memorization, we need to create a vector of int dp of size of n comma minus 1, and we need to initialize n as nums dot size. Now pass the dp here, pass the dp here as well, and dp here as well. Mm, Update the dp of I as ns, and check if dp of I, since not I, it is a pause, is not equal to minus 1, then we need to return dp of pause. And here we need to do pause as well. Now try to run it. Running fine. Try to submit it. Yeah, I got accepted here. Now it is a big of n square solution as we have memorized it. Now try to do the optimized solution for this problem. So here is the optimized approach. I am first of all writing the pseudocode, then we understand the approach. So here we need three variables. One is jump, which is 0, and one is current end, which is 0, and the farthest, which is again 0. Now the code is something like this. We need to run a loop from int I to 0 to I lesser than n minus 1, I plus plus. Update our farthest to the maximum of farthest, comma I plus nums of I, and if our I is equal to current end, we need to update our jump and update our current end to farthest, and at the end we just need to return jump. Now let's understand with the example. Now we are standing at the zeroth index. It is the value of the zeroth index is 2, so we can go two steps further. So the farthest we can reach from 0 is 2. So we need to update the farthest from 0 to 2, right? And check if our I is equal to current end, end or not. Our I is 0 and current end is 0. So we need to update the jump. So update the jump with plus 1. So it would be 1. And update the current end is farthest. So current end would be updated as 2. Now come to the next index. In the next index, the value is 3. So I plus nums of I is 4. And our current farthest is 2. So the farthest will be updated as maximum of 2 comma 4. So it would be 4, right? And I and current end are not equal. That's why we no need to check it. Move to the next one. When you move to the next one, 2 plus 1, which is 3. Our current farthest is 4. So no need to update the farthest. But the I and current end are equal. See, there is 2. We are standing at 2. That's why we need to update the jump plus plus. So it would be 1 plus 1 means 2. And update our current date as furthest. So it would be 4. Now come to the next one. When you come to the next one, it would be 3 plus 1, it would be 4. And the furthest is already 4. So no need to update the furthest. And if we see the I and the current end, they are not same. So no need to check about it. Go to the next one. When you go to the next one, we check 4 plus 4 is 8, which is greater than the furthest. So it would be updated with 4 comma maximum of 4 comma 8, which would be 8. And we reach I equal to current end, right? I and current end are same. That's why we need to do jump plus plus. So it would be 3 and update our current end as the furthest. So current end would be updated as 8. After this, we reach the n minus 2th index, right? Which is n minus 2. And our for loop will be ended for this condition. And whatever stored in the jump will be our answer, right? So our answer for this question would be 3. Now if you see which jump we are taking here, we are just taking 0 to 1, 1 to 4 and 4 to 5. These 3 jumps we are taking here. That's why our answer is 3. Now let's move to the editor and try the code. So here is the code for the optimized approach. So first of all, you need to know the size. Now the jump, current end, and the farthest we can go. Now we need to run a loop from 0 to n minus 1. Now farthest will be updated. Sorry, we need to do the second bracket here. Now farthest will be maximum of farthest comma I plus grams of I. Now if our I equal to current end, update our jump and current end as farthest. At the end return jump. Yeah, the code is running fine. Now let's try to submit it. Yes, I got accepted. And here the time complexity for this approach is big of n, and the space complexity of this approach is big of 1. Thank you.